We're going to take our lesson 2-4 notes packet. I'm going to create 2 videos from it. This is the first video, and this is about writing linear equations. And we already talked about one way to write linear equations back from lesson 2-2. So let me slide through here. If you remember, we talked about standard form. We looked at what standard form meant and what it looked like. AX plus BY equals C. We put that in green. AX plus BY equals C. But A, B, and C have to be all integers. The greatest common factor of them is going to be a 1. The A has to be greater than or equal to 0, so you can't have a negative in front for the coefficient of the X. And A and B are not both 0. One could be 0, so there could be no X's and one Y, or have some Y's, or there could be no Y's and just X's. So that's one form. The other forms, there's 2 other ones, is from this lesson. If you recall, slope-intercept form. It's in this box right here. There's also, it has it right up here, y equals mx plus b. But in the box, in this box right here, it reviews the parts to slope-intercept form, where the m is the slope, and the b is the y-intercept. So keep that in mind. So you look at your graph over here, the b is the y-intercept, would be the y-coordinate of that ordered pair, and the m would be the slope of that line. That's how that line is sloped, the rise over run. Now, that's probably, slope-intercept form is probably the most common way you'll see equations written. So we need to be able to take any kind of equation and put it into y equals mx plus b form. If it's linear, okay, we're focused on linear. We're not talking about curves right now. That'll be more advanced later on. There is a third way to write linear equations. We have standard form. That was from back in lesson 2-2. Here we're looking at slope-intercept form, which we use a lot. It's probably the most common one. But there is a third way of writing. I'm going to slide here to the back of that. I'll give you this sheet when you're in class. I'll give you the packet. But right now, we should be looking at point slope form. So in this key concept box, point slope form. Point slope form looks like this. Y minus y1. Y1 is the y-coordinate of a point that's on the line. And it's equal to the slope multiplied by the difference of x minus the x-coordinate of the point that you know is on the line. Now this is most valuable. This one is used most often when you already know the slope and you know one point. It's easy then to substitute those in and write your equation. Okay? So if you know if you know the slope and you know one point, you can put the coordinates in there, and you have this form of the equation, or of a linear equation called point slope form. And we want to be able to manipulate this. You should be able to change this form into slope intercept form, and even possibly standard form. It's just using algebraic manipulation and rules and properties. So I do want to show you one example here. You can look for more in your textbook. But here in example 2, right here, talks about writing an equation of a line that goes through 6, -2. There's a point, and it has a slope of -4. Since you know a point and the slope, we can use what we refer to as point slope form. Okay? So if you substitute in the 6 where the x1 is, that's your x coordinate, and then the -2 goes in for your y1, so it's a negative, so it goes inside parentheses, and then you take your slope of -4 and put it where m is, you end up with this equation And all you got to do now is simplify y minus negative 2 is y plus 2. Distribute negative 4 times x and negative 4 times negative 6. You get negative 4x plus 24. And to get y by itself to put into point slope form, to slope intercept form, see that? I get those mixed up. They sound so similar. But to go to slope intercept form, you want to solve for y. So all we did then here was to subtract 2 from both sides, and you end up with y equals negative 4x plus 22. Slope is negative 4, and this ends up being the y-intercept, which we didn't know before. All we knew was one point in the slope. Now we found out what the y-intercept would be also.